We left off last time in the middle of the section on periodicity with this periodicity lemma. And what that says is if you have a string S and it has two periods, it satisfies this shifting with two periods P and Q, and they're not too big. Then indeed you can take the greatest common divisor of those two periods, which is a smaller number, and then this will also be a period of the string. You will look in more detail at this lemma in the tutorials, so I don't want to go into further details of the proof. But I want to remark that smaller periods are, of course, like in this case, the 3, are of course somewhat more telling about a string, because a small period means a very long overlap, and these long overlaps are things that we can use or exploit. So what this lemma tells you is if you have two periods and they're somehow related, their greatest common divisor is not one of them, then you get a new, stronger period just automatically from this. For example, if you would be able to show that the string has a period of 3 and 5, those are co-primes, so the greatest common divisor is 1. That means the string is all A's. It's just A repeated m times. That's a fairly strong statement, coming from this somewhat more innocent observation that a string has period 3 and 5. So this will be used under the hood in these algorithms. Now, this was a nice definition. We have periods in strings, but what does this really tell us about strings? And there are two distinct regimes that people found useful to exploit algorithmically. And these are the periodic and the aperiodic case. And here we are really interested in the smallest period. This is the only, P will be the smallest period most of the time here, because that's just the strongest statement. Remember, it's the longest overlap, so that's the most telling statement about the string. If this shortest period is less than half of the string, that means we can overlap a string with itself, and there's more than half left, okay? Maybe I should be a slight bit more precise here in the lengths. If I can do this with my string, and these are all the same, well, because this is at least half of the string, I can find the string again. I can do the same. I can shift this over another time. And now what you see is this green part is also this green part. But hey, this says it's equal to this part, which is also here. And so that blue part is the same as the green part, which occurs here another time. But this has to be the same as this, and this has to be the same as this. So also this third repetition, this is all the same, okay? So graphically speaking, this and this and this, these are all the same strings. They're exactly identical. And so what this means is there's a smaller string, f, a factor in the terminology that people use for this. And this factor is only of length p, which might be much shorter than n. And s is essentially formed by repeating this factor over and over until you have n characters. So as you see here, we have 3 times the same string, and then there's some left over part at the end, which again it's the start of the green part again, but it's not an entire copy. Okay? And so this definitely means that S is repetitive, in that it consists of a factor that you just keep repeating. And if you think about it, we should be able to exploit this in string matching. If you have a long pattern that you're trying to find, but the pattern actually consists of just repeating a small same string over and over, we might as well search for the small pattern and combine the matches. Okay, so intuitively, this helps for string matching. There's also the other case, namely if this is not true, if the smallest period is longer than 1/2, then we cannot do this, because if we shift a string over by more than half of the length, if we would do this a second time, it would look like this, and there's no connection between the first and the third copy. So the only thing we can say about this string is that we cannot write it in this way. We cannot find a factor and repeat that at least twice and then have another prefix of it. The only thing we can say is that this is not true. So while the first case, a repetitive string seems to help for string matching intuitively, and also you can exploit this fairly easily algorithmically. The second case seems not to help. How should the knowledge about aperiodicity help us in string matching? Before we explore this question, I want to head over and get you guys active. So here is a string. And I just want to know if this is repetitive or not. And I only want to show you the results at the end, so you have a chance to vote without being influenced. So we had some 30 votes for the intro question, so I would hope that we get to our usual 25 for this question as well. Come on, guys. If you don't know, take no clue. This is meant to be your first intuitive answer to this. "23, come on, 2 more. We can do this. 24. Getting excited. Aha, there we go. 25. A roughly equal split. The correct answer is no, but the trick at this point is this string definitely looks very repetitive, right? It's a lot of A's and that's just one B sticked at the end. But that is not enough for being periodic in the precise sense how we defined it. The thing is here that the precise definition is it's periodic in this sense if you can overlap it with itself. And if you try to overlap this string with itself, if you do a lot of A's and then at the end a B, try to overlap this with, I don't know, say half the length, you would still have to put somewhere this A above a B. That never works. This string has no non-trivial period. You can never align the B with anything. The only option you have is to shift it entirely behind itself. This formally qualifies as the period N, but it's not an interesting one. So the reason I posed this fairly simple question is to warn you with these topics, sometimes people choose very intuitive terms, like periodic in this case. But be careful not to substitute an intuitive meaning for the formal meaning from the definition. The term is supposed to help you, and sometimes these are chosen well, and sometimes these are chosen not so well, not so helpful. But you should look behind this superficial name. You have to look at the actual definition. And in this case, even though this string surely is repetitive in some sense, it's not periodic.